All right, folks. Sorry about the delay there. Just finalizing, getting everything set up here. All right, so I don't have anything in particular that I'm wanting to go over. So I'm thinking it's just going to make sense to continue off from where we were with list basics, just for the sake of having something to do. If you have Python questions, go ahead and put them in the Slack put them in the thread under the message that I posted in Basic Prep. If you're coming from Premium Prep, the Premium Prep channel, I did post a link to the message in Basic Prep. So don't post your questions in the Premium Prep thread because I won't see them. I mean, you could, but I'm just not going to see them. So cool. We already got a question, which is great. All right, let's see what this is. Oh. Come now. There we are. All right. Cool. So we've got a link here, and I'm presuming the question pertains to one of the challenges. Okay. Yes. Okay. Good. So write a function called isNumber. I'm presuming it's this third challenge. Okay, cool. I'm just going to move forward with the assumption that it's this third challenge. If to the question asker, can you please confirm that that's what you meant? I'm assuming that it is because it's the same name of the function. Okay. So let me copy in their code. Oops. Okay, we've got Slack trying to be ultra fancy here. Nope. Come on, Slack. Come on, you can do it. Just... There we go. Okay. So I'm going to share their code. Oh, no worries. I don't mind. That's okay. All right, let's just see what this is all about. It says, write a function called isNumber, which takes in a string as an argument and returns the type as a string if the string is indeed a number. And the string, and it will also, I'm reading this as, and return, quote, not a number if the string is not a number. Okay. Note, if the string is a number, return its type as either int or float. You'll need to account for numbers with decimal point in them. An empty string should be considered not a number. Okay, so we have a few examples here. Let's copy these in. And I think what I want to do, I'll go, I think I'll go through the question asker's code here, and then I'll go through another solution. I'll kind of pretend like we have a... No, actually, I think I want to go through the solution first. Okay, I'll go through my solution here first, and then I'll come back to the original asker's code, and we'll go from there. Okay, cool. So 3.1. So this doesn't have a test for an integer. So the 3, this will be int. We'll do 53 will be an int. And I'll say this 53 will be not a number, 53 with a G in it. I'm wondering about a number with a space. I'm assuming that's not a number either. I'm assuming this is also not a number. But actually I can handle that in a single go. If there's a space in it, I'm just going to say not a number. Does this actually say how it wants to handle spaces? I don't see it doing that. Da, da, da. If the string is indeed a number, return. Okay. I'm just going to assume that if it has a space in it, it's going to be not a number. And we also want to see empty string, and we'll just do string with a space in it, also not a number. Cool. So these are all not a number results. Let's put these over here. Okay. So the pattern that I'm looking to get from these calls is float, int, and then all the rest are not a numbers. Good. So just to make sure that I'm going to get this correct here, we'll say print not a number, and quote int, quote float. Okay. I know that at various times I'm going to have to return one of these, so we'll just pop that in there for now. Tab that in. I'm going to make my function head now. So def is number, takes in string, and we'll say, okay, so let's start thinking about this. I think what I want to do is there's a whole bunch of like dead giveaways that will just tell me if the string is not a number. So I can just I can say if string space in string. Let's call this something else other than string. It's a little confusing. I'm going to use the word string for other things. Let's call this text like that. So if string of space in text, we're going to return not a number. That's easy. And I think we can even do like, yeah. You know what? Actually, I'm going to do this. We're going to handle this edge case, and I think I'm going to handle that space thing in a different way. We'll say if text equals empty string, then we'll return not a number, because we know we want to do that for sure. And I think there will be another place where we'll want to do this as well. So we'll just handle that edge case up front. And then I think I'm just going to go for character in text. We will see if C not in a string containing the number characters. So that's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, or period, right? So these are the only valid characters for a number, right? So if at any point C is not one of these, we can return not a number, just like that. Oops. Okay. What's another one? If there are more than 2 periods, so we can add to this condition. I could, well, let's make it as another condition first. So we can say if text dot count of periods is greater than 1, then we can also return not a number as well. I don't actually need to make this its own condition. I can check this in the same line. Since it has the same consequence as this other condition, we can just handle it right here. And I think just to break things up a little bit and make things a little clearer, we'll break that out into its own line. So let's run, make sure I didn't break the syntax there. I did break the syntax. Oh. Why do I do that? There we go. Okay, so the backslash is just going to tell Python, no, I actually meant to put that on the next line. It's just telling Python to ignore this line break and allow me to continue on the code from here. So that's what that backslash does. Okay, good. So I'm getting float, 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 and then the rest are not a numbers. So thus far, it can tell if it's not a number. All of these are actually passing, which is great. And it's giving me the correct result for float. However, it's giving me a float for int and int. So I need to hash out and teach it how to tell the difference between an int and a float. So we've already determined that if the count of periods is greater than 1, then we're going to return not a number. So that means either we have 0 periods or 1 period. We can either have none or 1, right? We can't have less than none. We can have negative dots in the text. So we can either have 0 periods or no periods. So I think I can say after we've verified that there's either none or there's 1, we can say, and after we've verified, this verifies that all of the numbers are, or all of the characters in the text are either number characters or a period. So we can just move on, and from here I can say if dot in text, then we know it's a float. If there's not a dot, then we know it's an int. Okay. Not sure this has exhausted every possibility, but we'll give it a shot. We'll see. So we get float, int, and then the rest are not a numbers. So this is matching the pattern that I expected for here, but I don't know. I'm not going to think about every curveball at this point. I'm just going to submit it and learn it and see if it accepts it. I'm fully expecting it to fail, but we will see. Actually, let me... We'll do that. I'm just commenting out that other solution so it doesn't get confused. And we'll see what it says. Oh, okay. I got it. Evidently that solution does work. Let's see what they suggested here. There's probably a better way to do it. We'll say, so if not string, this is the same as checking if it's an empty string. Since an empty string is falsy, not empty string is truthy, right? So, or the count of periods is greater than 1. So this is essentially exactly the same. It's written a little differently. They did not string instead of text equals empty string, right? Either way. And then it says check to make sure every number is either a digit or a decimal point. Okay, that's what I did. So for char, I did for C in text, if C not in 0 through 9 or period, return not a number, and that's what they're doing here. They put the period at the beginning. It's the same logic though. And they called it char and string, etc. A different naming, same logic. And then this says if the count of periods is equal to 0, then we know it's an integer. Otherwise, we know it's a float. And I just checked the inverse condition. I just said if there's a period in the text, then we know it's a float. We know that because we know there's not more than one period, because we already checked for that. And if there was, we already returned, and the function didn't even make it to this code. It's already returned the correct value at that point. So I did that a little bit differently, but it's doing the same thing. So sort of surprisingly yet not surprisingly, the implementation details here are different, but I think the line of thinking is exactly the same, right? We just check our edge cases. If the string is empty or there's more than one period in it, we're just going to say it's not a number. Then we go through the string, we check to make sure that every character is valid for it being a number, and then we check the number of periods, and based on that we return enter float. Cool. Okay, so let's look at the question asker's code and see how that's going to work. Cool. So I'll do this here, pop that over here. Oops, forgot to copy this. Okay. Copied that, and then I'm going to copy my tests down as well. Cool. Oh, they have a call in place already. That is interesting. Okay, whatever. So let's just run it and see what happens. We have a call, and we'll just see what's going on. Okay, so right off the bat we get invalid syntax, and I think, yeah, that's what they're saying. They said this is what I had, and it returned a syntax error for elif. Okay, cool. So why does it give us a syntax error for elif? Oh, yeah, I helped somebody else with a very similar issue today. A lot of times when you get a syntax error on like a condition or something, because obviously elif itself is valid syntax, I look at the line above it, because I'm looking at this elif type val equals int. This seems, I don't know, rational enough. It seems like valid syntax at least, unless I'm, missing something. But then I look at the line above it and I notice the parentheses here don't totally match. So I get this float val, and this has parentheses for this. And then I notice that's being passed to type. But the problem there is that type doesn't have an ending parenthesis. So there's something that I do to combat this, because this is an easy enough thing to have happen. What I do is I always put spaces in like this. To me, it's visually easy to see if this is complete. Like this is obviously incomplete, whereas this is obviously complete. Whereas if I don't use spaces, the valid line, comparing the valid line to the invalid line visually is more difficult, right? It's harder to tell like that. So I like to use spaces. This is just totally something that I do. I use it a lot and I like it. Um, I never do it on the innermost term just because I don't really feel like I need to. I feel like it's almost always obvious where that begins and ends. If it's not, you can add it in there. It's just a little trick that I do just to make it a little visually easier to tell. So let's see what happens when I complete that in parentheses. Okay, so this says this is the error that I was expecting. It says name string is not defined, right? Well, if you look up here, you might look, well, it is being defined as the parameter in the function. And that's true. However, you may recall when we talked about the local versus global scope, this being a parameter to the function is local to the function and does not exist outside the function. And you might look at this and you might realize that this is, because of the way it's tabbed, right? It's tabbed all the way to the left, which is the same level that the definition is on. So it is outside the function. If it were tabbed in anywhere in there, it would be inside the function, which we don't really want to do because this would be a recursive call and this is not a recursive solution, so you don't really want to call the function inside of itself. Not this function, at least. So we have to define some string. We have to actually give it the data for the string. And this will return not a number since the word string is not a number. And let's just look at the logic for this. And we'll see float, int, and then not a number is all the way down. Okay. Cool, so we actually get a value error here, right? So this is actually going to tell us that it could not convert the string to a float. And then it shows us the string that it couldn't convert, and it's 12.5234 .15. And that's because this is not a valid float. It has 2 dots in it, and that's not a valid float. So, in this case, yeah, let's look at where this error is happening. It says it's happening on line 28, and that'll be right here. This float val, right? So if we commented this out, we're actually going to get the same error again when we return type float val. But we could just say, in this case, we can just return float. That's what it's expecting. So we'll just do that. And we'll do the same thing for int as well. Cool. So notice we get none for the 2 second to last ones. And I'm just going to move this one up to the top since that's sort of more belongs there. So for the integers, it's saying not a number, and for floats, it's saying float. Okay. Or for this non-float, it's saying float. So what we could do for this, I would do that check up above, just that same check, just to like cover the edge cases, which would be multiple periods and empty string. Right. So if we'll do like they did, not string, and well, I'll do it like I did actually. If string equals empty string, we'll do backslash, or string dot count period is greater than 2, excuse me, greater than 1, then we'll return not a number. I've had a number of people, I wanted to add this particular bit in because there's a convention around this, and I've had a few people, I think, get really confused by this. Here, let me actually put this on one line so it's less confusing. This is probably more how you're accustomed to seeing this. I've had a few people ask, like, how do I know, like, when to do my checks in front, when to run conditions in, like, at the very top of a function. And it's something that, you know, people want to do at the end, like, why do this here instead of like down here, right? Like, why not do all your main logic and then check your edge cases? Because a lot of times your edge cases are things like that will essentially invalidate your primary logic, right? Um, they're they're things that you can check to just get out of the way to determine whether or not you should go through with the rest of the function. In this case, if either of these things are true, we can just return, which is going to avoid executing any of this code, and it's just going to return not a number right out of the gate. And we can, yeah, just kind of save some time that way. Okay, so let's run it and see what that improved. Oh, I gotta actually scroll down. Good. So I get float, and then all not a numbers, and then none at the very end. So that is because I don't have a way of handling space as a character. So this is, so let's, I want to see if I can kind of turn this into a working solution without just, I might end up just turning it into the solution that I had essentially, but we'll see. We'll see what I can do. Okay, so this says if dot in val return float. So this is great. And this doesn't need to be in, we don't need to check this every time through the loop, because if it's not in the val, we've, you know, like nothing in here. Oh, actually, excuse me, we can just check the whole string. We can do the whole string there. And we can just do that outside the loop. I did that at the end, like this. And that's how we know when to return int. We don't actually need to split the string in this case, because we'd be splitting on spaces, and that's actually useful information. We actually want the spaces, so instead of val, I'm going to do, we could call it C. Is that what I called it in mine? Yeah, of course that's what I called it, because that's what I always call it. C for character. And just by habit, when I'm looping through a string and I want an instance of every character, I just call it C for character, just, you know, like I know what it means. So that's my own little convention around that. And we see if the type of C is equal to an integer. So this is an interesting one, because this is saying if the type of C is equal to an integer, but the funny thing is the type of C is always going to be a string. No, even if it could be made to be an integer, and we can prove this. So let's do type of the string of 42. So what's the type of that? 42 is an integer. 42 could express an integer, but the type of the string 42 is a string, not an integer. So, so this is checking the type of a string, and we know it's a string because it's a character from the string. So that'll be fine. All right. So again, we can move this down essentially to be the other sort of inverse condition of this, and I could just make this an else. I am turning it into the solution that I had, unfortunately. So this is if the period is in the string, then we know it's a float. Else it's an integer, right? Because at this point we've already determined that if there's a period in it, there's not more than one period. So it could be one period, in which we know it's a float, or it could be two periods, in which case we know, or it could be 0 periods, in which case we know it's an integer. Okay. So now all we got to do is just make sure that all of the characters in the string are valid for either integers or floats. So check for membership, we'll say if C is not in a list of valid characters, since that's shorter than the list of invalid characters in this case. The list of valid characters is going to be period 0 through 9. Okay, let me make sure. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. If it's not a member of this string, then we're going to return not a number. And there you go. I've literally just turned it into the original solution that I had. So yeah, sorry for that. I try to get into like how people are thinking and like try to make your solution work, but I think like I think. Can't believe I just said that. I think like I think, and that's why my solutions come out this way. So cool. Good thinking, by the way, is creative. Okay, so I'm noticing the person has some follow-up comments using logic. Yeah, sometimes that can be a tricky one. Like if you get an invalid syntax error and it's pointing at a line, and you look at the line and you're like, that is valid syntax. Start looking at the line above it, immediately above it. If that doesn't give you something, keep looking. There's something called error distance. Um, Error distance. I mean, it is what it sounds like. It's when the interpreter throws an error, it's going to do its best job to try to locate where that error is. Python does a really remarkably good job. It has generally a really low error distance, but there's certain scenarios where it doesn't get it totally right, and the distance from where it said the error was and it thinks the error is to where the actual error is might be a little bit different. So just know that is a possibility. Generally, it points to the right thing. If not, then the error is probably close, and it's probably above. The most likely next culprit is the line of code that you wrote immediately above it, right? If the line of code is blank, if it's like just a blank line, then it's probably the code, above that, etc. Missing parentheses, especially missing ending parentheses, is a really common thing. That happens all the time. So yeah, that's a good one. It's good to pay attention to. So I'm just going to read the comments that the question asker has been leaving. So that makes sense to check for quote period. In strings, or in the string, for some reason I was thinking to check each one by one, but checking for membership in a string is way easier than now that you mention it. Yeah, yeah, that's also another. I think checks for membership can be like this is sort of just a facet of programming and programming in Python that can be overlooked. Checks for membership in general, yeah, you can get a lot of mileage out of checking for membership. Um, uh, in a number of different ways. Um, it's a really useful feature. Okay. So, listing some takeaways, they're saying, I learned from this. Number one, with errors, I need to check the error line above. Yep. Number two, need to be more observant with regards to what the question was asking. There was an example containing 2 decimal points in the answer, so that was a tell. Conditional logic was an option. Mm-hmm. I learned better by trying a few new ways before watching the video or asking. Yeah, exactly. Yeah, experimentation is um, an excellent approach. Streaming quality issues. Okay, somebody's saying something about the streaming quality being low. Is it really 360p? That's really low. Let me look at this. I'm worried about like pushing it up too much. Sorry if it's a low quality. Um, I think the best thing I can do for now is to just blow up my text, like to a very large degree. Is that um, more manageable? I will work on future streams being in a higher resolution. I think uh, what I wanted to do for this one is to get just make it at least workable. So if it's stable at 360p, I think that's better than nothing. But if that's an issue, I will work on it for the future. Cool. All right. Um, Let's just go through this. This then. Yeah, let's just go through the challenges for this. Basic string properties. So true or false, what is the result of the following Boolean expression? List of string brackets equals list. So these are not going to be equal. This is interesting. So these are not equal. So if we run this, we're going to see that that's not equal. Actually, I'll just take out this equal and I'll put in a comma. That way we can see them next to each other. Okay. So you can see that the list that we get when we're making a string out of this list, it literally contains every single character in this string, including a string of the square brackets, which is kind of confusing. So the list that it gives us, let's see if I can paste this in a more intelligible way. So the list that it gives us is here, right? It starts here with this square bracket, and then it has a string of the character of this square bracket. So it literally breaks every character, including the square brackets, including the commas, and including the spaces, into its own element of the list, right? So here's our square bracket, and then the string of the number 1, and then a string of the comma from the original string, and then a string of the space from the original string, etc., etc., right? So those two aren't going to be equal. If we did this, that would be equal. Oh, no, that's not equal. That is not equal. Oh, and of course it's not. Yeah, okay, so that's interesting. So let's look at this as well. Let's see what this gives us. It's going to be a little funky. So, this does give us a list of 1, 2, 3, 4, 5, but notice 1, 2, 3, 4, 5, when we converted it, is a list of strings, whereas the list just contains a list of integers, right? So we might do like something like map int to that, and then we'll see. I think that'll give us the same. Yes. So this will give us the list of integers, right? And the reason is, so what I'm doing here, let me get some of those spaces in here. I'm kind of crammed in. What I'm doing here with map is map allows me to apply a function that I hand map as its first argument, which is, in this case, it's the int function. So it's going to apply this int function to every element in the collection, which is map's second argument. So I take an uninvoked function. So notice I don't have parentheses after int. So I want to pass it the name of the function to invoke, and it will invoke this function internally for me. And it's going to apply this function to every element in this collection. Total tangent here. Let's write a map function. Def my map takes in function, an uninvoked function, and a collection. I'll call it a sequence. And it will output this map, the built-in map, outputs it's technically called a generator function that outputs as a generator. I'm just going to do a list. My map is going to output a list. So we'll just say list equals empty list. Basic accumulator pattern will say for L element in sequence list dot append. Now here's where the magic is. I'll say func and then parentheses element. So element is the element from the sequence, and func is my function. Since this is an uninvoked function, I can call that function. I can just assume it's a function and treat it just like a function there. And then after that's done, we'll return list, right? So this mymap function that I just wrote, it's a little bit different, but it's the same idea, right? There's other things like if I pass another, I think another collection, it'll apply the elements in that collection to the second argument of the function that I passed to it. So there's, or I might be getting that wrong, a little bit wrong, but map has a way of handling functions that have multiple arguments, in my case, the function that I pass can only handle one argument to it, but uh, that'll work. Let's actually use it. It's not that cool unless I actually make it work. Cool. And then in this case, I don't need to cast it to a list. There we go. My own map function. And that'll work. Cool. Will somebody confirm if the larger text makes it more readable for now, even if it's in a lower resolution quality? Also, if the streaming quality is really bad, throw an F in the chat, and that'll let me know that the streaming quality is bad. Be able to deal with it better. Cool. All right. Didn't necessarily mean to go over map today, but that's good. I'm glad. I like map. It's a useful function. Okay, cool. Moving on. Basic string properties challenge. Write a function called char count, takes 2 arguments, a string and a character. This function should return the number of times the given character appears in the string. Okay, so this is a wrapper for the count function. So we can say def char count takes in stir, we'll call it text and ch for character, and we'll return text dot count ch. And I'm not even gonna test it. I think that'll do it. We'll see. Oh, it did work. Okay, cool. So takes in string and char, return string dot count char. Okay, so this is actually interesting. So it's saying, why can't you use an accumulator pattern here? And it says you certainly could, but stir.count is generally much faster at iterating over the entire string. That's a good point. We could do this as an accumulator. This is one of those things like where an accumulator, it's a simple but very powerful abstraction. So we'll call this, let's just call this count equals 0, and we'll say for element, or we'll say for C in text, if C equals ch, which is our input, then we'll say count zount, which is like count, plus equals 1, return count. Yeah. Boom. Boom. Oh, why did I do that? Why did I click there? I'm just clicking around, messing things up. Okay. Da, da, da. So we'll try that one out too. Did it? Meh. Okay, char count. Hmm. Okay, that's interesting. Very interesting. 0 is not true. Ah. That's interesting. So what does it want? What does it want when both strings are empty? It doesn't want to return 0. So what does count return? So if I count on an empty string dot count empty string, what does it return? Returns 1. That's interesting. So I think I'm just going to handle this like if text equals empty string, return 1. Okay. Wah, wah, wah. 1 is not false. Whoa. Oh, let's do this then. If text plus ch equals empty string. Cool. All right, so I'm concatenating these two, and if I get empty string plus empty string, it should equal empty string. So if I'm saying, this is like saying if both are an empty string, then we'll return 1, else we'll return false. Okay, so this would be an accumulator pattern solution for this, and that's kind of an uphill battle with this one. I think it's better with, actually let's save that. So I think the count solution is much cleaner, obviously. So we'll say return text dot count ch. Bingo. Good. Also, if somebody could confirm if making the text size larger, somebody is saying that the max resolution right now is 360p, which I will fix in future streams. I'm going to leave it for now. Just if somebody can confirm that making the text size larger if you're in 360p actually made it more readable, that would help me. Cool. And then what was this one? Oh, it deleted my solution. Let's see. That a function calls. Okay. I'm going to just rewrite this from scratch. And I'm going to do this thing where you just saw me solve this problem. You know I can solve this problem, but I'm going to try to solve the problem and with the expectation that it's going to run the first time. Actually, with the expectation, I'm going to try to get it to work the first time, but it's probably not going to work the first time. And I just want to demonstrate this just to show you that without running your code, it's okay to expect it to fail. And it's probably going to fail. Okay, somebody's saying it's readable. The text size looks great. Okay. Thank you. Can we have the accelerator as an empty list? Presumably you mean accumulator? Let's see. For count, somebody's asking if we can have the count be an empty list. I'm not quite sure how we would do that. Maybe we would just do this, and then say count dot append. What would we append? Well, I guess we could append C, and then we could return the length len of the count. Let's see if that works. Interesting way of solving this. I think there's a way of making this work. Okay, didn't like that. Oh, right, I needed to... Right, let me do this. comment this real quick. And then I think what if I just do that? Okay, so I forgot that edge case condition at the top there. Okay, so that does work. So we could have count be an empty list here. This will work. Excuse me. This will work. It honestly seems counterintuitive to me to have it be an empty list because when I get to this point, there's no clear thing to append. So I'm just like, well, I guess I could append C just to give it a length. And then at the end, I can take the length of it. And then I know how many times C appeared in there. But I end up with this list in memory that's just a list of the same character of some length. So, you know, like if that's your first tier solution, you know, like you're producing working code, that's what counts. But there is some, you know, I would say that there would be some cleanup that you could do to that. Cool. So now back to this watch me fail stream on isNumber. Okay, we'll try my first no running the code allowed, and it's probably going to fail. So write a function called isNumber takes a string as an argument and returns the type as a string. Okay. So it takes text as an argument, and we'll say, oh, I just solved this. I'm going to just try to hammer my way through without thinking about it too much. If text dot count periods is greater than 1, or text equals empty string, then we'll return not a number. Otherwise, we can for C in text if C not in period through 0 through 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oops. Return, same line here. Copy, paste. Return not a number. I think that's good there. If dot in text return float, else return int. Fully expecting it to fail. We'll see what happens. Oh my gosh, I got it right. I honestly didn't expect that. I thought I would make a mistake somewhere. Well, too good for my own shoes, I guess. Alas, I was hoping I would make a mistake, and then you'd get to see that I make mistakes too. But I you know, okay, whatever. Let's see. Now I want to clean it up and make it nice and pretty again. I'll do that. I don't know why it deleted it. It's so weird. And then actually, I like doing that condition second. I'll do that one there, and we'll say or, and I like my backslash, and we'll do that. I wonder, I don't think it's going to let me put it all on one line like that. No, that's a mean, nasty line. I don't like that line. That's a mean line of code. Okay. Do that, else return that. And that is nice and square. Excellent. Beautiful. To the person who asked about having the accumulator set as an empty list. It seems like you got your question answered. Am I right about that? Cool, and we've got another question. Awesome. Thanks for the questions. This makes oops, this is what study hall is all about. I appreciate it. I know you have to be a little bit vulnerable and like show your solutions. I'm not saying people's names and stuff on stream just to give you a little bit of a barrier from just having your solutions be like right out in public. But I appreciate you sharing your code, and I think that's what really makes stream come alive. Makes it fun. Okay. So we've got some code. The person who just sent in the last question with the code, if you can give me a link to where this problem is in Learn, if it's in Learn or if it's on Code Wars or whatever. Oh wait, is this one of the ones from here? I don't even remember anymore. Char count. Oh, okay. It's right. I found it. Yeah, I was like, this is what we just did. This as they're saying that this is giving an error. Okay. Print char count. Oh. Did I have? Oh no, I didn't even have tests for this. What am I talking about? We'll do this and L because there's 3 L's in there. So for this call, we expect 3. Good. Okay, let's see what this gives us. Oops. Just want to see if it's running properly in my terminal. Okay, so that it says that's worked. Oh, right. Sorry. This is because it's not. This is what I tried initially, and I forgot that I didn't add that condition in. So in order, because I had basically the same code, but I left that condition off, so it yelled at me for that. So this is going to say 0 is not equal to true. This is not a super useful informative error, which is kind of fine. Some errors aren't. But I look up here and I see the invocation that failed. It says it's from line 11. This is in test basic, which is not a document not this document, right? That's something behind the scenes in Learn, and it's testing it. This is the call that's failing. So it's basically telling me that I need to handle empty space in some way. So what I determined was that it wanted to see if both arguments were an empty string. I said empty space. What I meant was empty string. If both arguments are an empty string, it wants us to return a 1. The way that I did that was I said if adding the two together, text plus ch equals itself equals an empty string, then we know they're both empty strings. It's like 0 plus 0 is 0. That's essentially the string version of this. So if 0 plus 0 is 0, if there's no characters in here and there's no characters in here, and that, then that equals an empty string, and then we can just return 1. So, yeah. There we go. Cool. Cool. Make sure I have that. I did not have that in my code. Boom. Okay. All right. Good. Let's do that one, and we'll run tests. I'm such a completionist. Why does it say I didn't complete everything? Must complete all the things. False. Oh, yeah. Hooray. Oh, basic string. Let's just go to here. Basic string operators. Kind of having fun. Oh yeah, sure thing. Yeah, it's easy to forget about empty strings. Everybody forgets about empty strings. They're um, forgettable. But it's funny because you do have to handle them. I mean, learn kind of holds your, puts your feet to the fire in that regard. But it does it because we wrote it to do that, because an empty string is a valid string. It just doesn't have anything in it, so you have to find a way to handle it in the real world too. Cool. So let's see, basic string operators and methods. This is before the one we were just working on. Use arithmetic operators to perform string operations, understand string concatenation, interpret code using operators in the lessons. I just want to do the challenges. Give me the challenges. Okay. Given the code below, what will be printed? I wonder how this will work. X, Y, and Z. X plus Y can plus Z. So I wonder how this will work. Notice some of these look a little like maybe there's a typo or something. But if we look, some of these have spaces in the beginning, right? Or, well, just this one. Just Y has space in the beginning. So we know there's going to be a space between I wonder and how. So that's all of them. And then, is there going to be a space between will and work? The answer is no, because there's not a space after will for the string that's equal to that Y is pointing at. There's not a space before work for Z, so will work will be one word. So I wonder how this will work, where will work is one word. Let's try that out. It's going to be correct, because of course it is. What's the value of Y after this code runs? X equals 3, Y equals X times 3. So that's going to be 333. Notice this 333 doesn't have quotes around it. Tells me it's an integer. This 333 has quotes around it. Tells me it's a string. So it returns 333 as a string. Looks like I did this one already. I'm going to just delete it before I see it. Basic string operators. Probably did this in a previous study hall. I'll write a function called repchars, which takes a string. Let me just pop this on the end here, just so I can like save it if I want to reference it for whatever reason. Takes a string as an input, meaning an argument, and returns a list of strings as an output. List of strings as an output. Okay. Each string in the output should contain a unique non-white space character from the string repeated the number of times it appears in the input string. Funny. Okay, so I am a string. Okay. The function should be case sensitive. If the character only appears once, it should not be included in the output. Got it. Okay, so repchars. So this has tests. I'm going to work in my terminal because I like it. There we go. A little crammed due to the extreme text size here. Okay. Oops. I'll print this. Print. I'll just pop this on its another line. And we'll say print. This will take in text, and we'll have list equals just an empty list. And then I think I just want to do for C in text. For C in text, let's just print C to start off with. Make sure it's going to be what you think it's going to be. Okay, we get the alphabet there. I'm kind of reading from the bottom up. We get none, and we get bang, bang, bang. So it looks like I'm getting the characters, which is what I expected. And the functions are returning none. Return, forgot to return my list. Return the list right off the bat, just so we have something to do. So now I want to list.append C times text.count C. Okay. Oops. Okay. So this is a little wrong, but we'll see what it does. So this gets me all of the characters, including spaces. It's interesting. So spaces show up in this string multiple times, but they're not represented in there. I don't think it says that. Oh, non-white space character. Okay, so let's just get that out of the way first. So if C not in, and we'll check our white space characters. That'll be space, and I doubt it's actually going to test for new line and tab, but I'm going to put it in there since those are our white space characters. I'm sure it's just going to test for space, but I'm going to check if C is not a space, a new line, or a tab, then we can append it. So this will be a little bit improved. Cool, but we still have, like, we have AA in here multiple times, and we have all the strings that appeared once, right? So we'll say if so let's also say if the text dot count of C is greater than we'll say greater than or equal to 2, right? So if there's 2 or more, and that'll include 2 since we're saying equal to, then we'll append it. Okay, so now let's see what we get. Okay, so we get AA, bang, 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 bang. Okay, cool. So a couple problems. Our second test here is passing. We're getting an empty list, which is great. But a couple problems, we don't have those I's. And if we look, it's because we have a capital I and a lowercase I here. So this tells me I want to do everything lowercase. So I want all instances of C to be lowercase. So I'm going to pull C from a lowercase version of text. So if I lower text here, this returns the text where all the characters are lowercased. And then I'm pulling C from an all lowercase pool, right? So let's see if that works. I hope you see how much I'm running this code, right? Oh, interesting. Oh, I still did not get I. Oh, it's very interesting. Okay, so let's see. I'm just going to comment this out. I'm going to see if I'm going to print C, and we're going to see if this very first element is a lowercase I. And it is. Interesting. Ah, I know what it is. I'm doing the count of C in text, which is still uppercase. So you know what? I don't think I even need access to uppercase text. I'm just going to say text equals text dot lower. We're just going to get the lowercase version, and that's just going to be text from now on. So we'll just save that, and we'll see if that's actually going to give us I's. Okay, great. So we get II, then AA, and then AA again, II, and then 3 triple bangs. So I have repeated elements in here. So what I want to do is I want to run this append only if this is not in append in the list already. So we'll say if this not in list, then I'll add it in. Let's see if that works. Great. AA, triple bang. Oops. And let's see if we still get an empty list or if we broke that. Good. Okay. I don't need this print. Save that. So this is producing the correct output. And I'm assuming this would pass if I passed it into learn here, but there's an optimization. There's a way we can improve this. These can be rewritten as ands. And we can actually make this one condition. We'll do backslashes there. We could actually, real quick here, we could put it on one line. It doesn't look like it's on one line because it's wrapping around because I have the text is scaled up to such an extreme here, but I'm going to put them on different lines like this because I think it reads better. So we have each of our conditions, and it's only going to run this append if all 3 of these are true, right? So if C not in the white spaces, so if it's not a white space, and text.count of C occurs more than more than once, twice or more, and C times text.count C not in list, then append C times text.count C. Good. Maybe yeah, well, that's fine. We'll just do that. Cool. Should work just as well. So let's copy that. Let's paste that in there. Let's give that a run. And we'll see if it works. It sure did. Okay. Let's compare their solution. We'll just take a look at my old solution, see if it was anything like my new solution. Somebody's asking if we have time for another question. Go ahead and throw it in. Oh. Sorry, you did throw it in. My bad. I just read the first part. Okay, cool. I'm just going to wrap this up, and then I'll get to your question. So their solution is lower string equals string.lower. That's what I did. I just overwrote text. I didn't make a new variable. Same difference, I guess. Initial collectors, letters seen, and results. So it looks like they're taking a little bit of a different approach than me. And they're saying for char in the lowercase string, char count equals string lowercase string dot count of char, and then if char count is greater than 1 and not char dot is space, this is checking the white space. There's a method that returns true. String method is space that returns true if the string it's being called on is space. And that's the same thing as what I'm doing, saying if C not in space, new line, or tab. Um, and it's also checking and char not in letters seen. So this is what's controlling the you know duplicates, right? In my case, I'm saying if the char count is not in the list already, they're doing it letters seen. So if all three of those things are true, then we result.append char times char count, and we result or letters seen.append char, and then return result. So it's a little bit of a different solution, but I think kind of same idea. What? Here's another solution. Is this the same? Oh no, they reduced the. Oh, I see. It's interesting. So with this one, looks like. So here's an alternate solution using set. Oh. Oh. Right. So with this one, they go through lowercase string as a set, and this means that each element will only be represented once, and therefore it'll only be checked once, right? So this is a great example of how to use set to remove duplicates strategically. So this will essentially remove duplicates, meaning we'll only check everything once. So we don't have to worry about checking if it's a space or whatnot. I like that idea. That's a good one. I think I'm going to do that. I would not have thought of that. Cool. But that's the nice thing about reading other people's code is like you see cool other different ways of thinking about things, and that's how you learn, right? So this is something I'm going to add to my repertoire. Next time I have this is, like, oh no, I'm checking duplicates. How do I avoid that? Well, I can just take from the pool that I'm checking from and turn it into a set. And then once I have it as a set, I don't need to worry about handling the eventuality of duplicates if I know that I never want to deal with duplicates. So that's a good optimization. That's a really good optimization. Cool. Actually, I'm going to do this. Make sure it still works. Lovely. Run tests again. And let's see what my original solution was. Oh yeah, I think I had helped somebody with this one. Oh yeah, I remember, right. So I did this checked chars thing, and I did white space characters. I started it off with white space characters, and then accumulated more characters into it as I went along, and this just automatically helped me avoid duplicates and white space characters. So basically, I'm just starting checked chars like this by saying like, hey, I already checked new line, white space, and tab, and determined that we don't want to check those, right? So the condition is if C not in checked chars, but by right up front we're not going to check new line, space, and tab, and the count is greater than 1. This is interesting. So yeah, this is actually really interesting because I do remember writing this code. God, I think maybe it's been not that long ago, maybe a week or two ago, maybe even really recently. But this is a really different solution, fairly different solution than I came up with this time. So that's interesting. I don't often do that. I don't often solve a problem twice with such a different solution. So kind of cool. All right, cool. I'm going to take that question that someone posted, and then I think we'll wrap up after that. Oops. Okay, fine. We'll just go here. And let's look at their code. Oh no, Slack, please just. Oh, for the love of everything that is easy to deal with, Slack, please. Okay. I'm just being complacent or complainy. That's what I mean when I say complacent. I mean complainy. We'll put that there. That's the code that they sent me. And then this solution, I'm going to actually cut. And I'm just going to put it in here. Do that and that. Good. Okay. So they're saying challenge 3. Let's see what it is. I haven't done this one yet. Okay, in the code cell below, use list iteration to accomplish the following. In a list called even nums, append the even nums from the original list iteration list. Similarly, in a variable called even idx, collect all the values which are associated with the even indices from the original list. Okay, and specifically they're asking, I can get even nums to collect, but I'm having trouble returning even indices. About it, I commented it out, so okay, cool. Let's see what this code is doing. I'll start with their code. So iteration list, list of the range 1 to 1000 in steps of 3. So even nums and even idx. So what? Similarly, in a variable called even idx, collect all the values which are associated with the even indices in our original iteration list. Okay, cool. So for I in iteration list. So that's the element. If I mod 2 equals 0, yep, that tests if it's even, and that's appending evens. I'm just going to get rid of these comments. So we don't have all, this code doesn't give us all the pieces that we need to work with. So we actually need access to the index, and actually I see that I think this was the intent of this line here, to create something called idx equal to iteration list sub I. So I is going to be a number starting at 1 in steps of 3 up to 1000. So first it'll be idx will be iteration list sub 1, then it'll be iteration list sub 4, then so this isn't really going to give us idx, unfortunately. But what we can do is we can actually use enumerate. If you find yourself in a situation where you want to access the indices in a collection as you iterate through it, the indices associated with every element, you can use enumerate. The first part of what enumerate returns a tuple every time. The first element in the tuple is an index, and then the second element is the element from the original collection. So I'm going to Actually change this to L because that's the naming convention that I like. I is fine, you do you. So let's save that and see what happens. Right, okay, so we get our even nums. Now we want our even indices. So we'll say if idx mod 2, we're just going to see if idx is even equals 0, then we'll even idx. And then what did it say? Okay, so similarly in a variable called idx, collect all the values, all of the values. Okay, so that's what I'm calling elements. All of the values which are associated with the even indices. Okay, so I didn't know if it wanted idx here or element. It looks like it wants element, so we'll do that too. Bingo. Very nice. Don't change the original line of code, eh? Okay. Oh, I didn't even write my code below. I just totally ignored what was in learn. There you go. Not that it makes a difference. Okay, cool. It looks like I got it correct. See what they did. Initiate the variables for val in iteration list. Oh, they're just doing this in 2 different loops. It's a kind of more brute force way, but if it works, same sort of deal if it works. So if val in iteration, if val mod 2 equals 0, then append it to even nums. And then the next one is for idx in range of the length of iteration list, if idx mod 2 equals 0, then append iteration list sub idx. So they're doing this a little bit differently. I think enumerate is good to go here. I kind of feel like there's a way to yeah, I think this is about as tight as I can get it, just off the top of my head. Like I smell an optimization to be made, but it's also not jumping out at me, so I don't want to think about it that hard. Cool. To the question asker, let me know if that helped, or if you still have questions, or if like if what I just went over was nonsense and doesn't make any sense. Let me know, help me out, and I'll do my best to clarify anything. Meantime, I'm just going to do these ones. What will be printed out on the 11th iteration through the loop? I don't even know. I don't want to think about it. I'm in a lazy mood today. I just want everything to be very easy, and I'm just going to print it out. Yeah, so many. For I in range x, print I squared. Is this just going to be where I is, we're starting at 0, so 0 to, okay, 12. That'll give me, oh, I'm just being so lazy. It's wonderful. So 10. Oh, I think it's just going to be 100. Yeah. There we go. It would have been easier if I thought about it. Cool. So loop, number of trips through the loop, value of I, what's printed, right? So loop 1, 2, 3, 4, 5, 6, 7, 11th time through the loop. The value of I is 10 since we started at 0. 10 squared is 100. So as they're saying, it makes sense. Would be beneficial to start proving pattern. Awesome. Cool. yeah, that's one of those things in terms of pattern recognition. Like I always think about keywords, like or words that when I say them, like I kind of do this thing where I have like an internal dialogue about like describing the problem to myself, and when I think like something something index something something, I'm like, oh, I might need to use enumerate here, right? It's a good signal if the problem mentions index, you very well may need to use enumerate. Cool. So what'll be printed on the second iteration through the loop? So x is equal to a list. The list has two lists in it. Both of the lists have are lists of ranges. The first one is 0 through 5. The second one is 5 through 11. So the first one will include 0 and exclude 5, so it'll be 0, 1, 2, 3, 4. And the second one is 5, 6, 7, 8, 9, 10, excluding 11. So the second iteration through the loop is going to be a list with 5, 6, 7, 8, 9, 10. Correct. Cool. I just did that one. All right, cool. That seems like a good place to wrap up study hall for today. Appreciate everybody who asked a question and participated. Like I said, I know it can be, you have to be a little vulnerable and willing to share some of your solutions and whatnot. But I do appreciate you participating, and everybody who just hung out and is watching. Awesome. Thanks for showing up. Uh, like, comment, and subscribe and all that if you're not already. Um, or, don't like it if you didn't like it or whatever. I am open to feedback. I didn't know that the resolution was so low on this stream. So I will be working on that. I'll try to get things into a better resolution in the future. We were having problems with the streams just being intelligible, so I think, like worst comes to worst, I'll just have to blow up the text size in my editor to this really big font, and we'll be able to like limp by on 360p until I can get a more stable, higher quality stream. But I will be working on that. So yeah. And I'm like I said, I'm open to feedback. If you're in the Galvanize Slack channel, just find me and DM me and say like, hey, I think the stream could be improved in this way, or like, hey, you're a hack and you're a farce, and well, maybe don't tell me that. I don't want to hear that. But give me constructive criticism. I'm open to that. And ways that can improve stream. Also, if you have other ideas, if you have questions, I'm open to all of that. So, yep, it's been a pleasure. And if you're in Premium Prep, I'll see you in a little over an hour when we start there. I'll be teaching tonight. So, yeah, pleasure as usual. Have a great rest of your night.